Okay, so these are 2.4 notes. Let me write that up here. Oops. 2.4 notes for transforming apparent functions. And we'll be just doing mostly just the general form, and then we'll also be doing a similar activity to what you did last year called Move the Monster. So this is given the graph of y equals f of x, describe the effect of each transformation. So many of these we've reviewed throughout the year, but let's just make sure we understand everything. So when you're adding a value to the x as the input, that is going to be left a. Okay, minus a, that would be right a. Now both of these fall under what we would call a horizontal shift. And if you remember, these are basically opposite of what you'd think. So this is y plus a was to the left and minus a was to the right. However, when the plus a and minus a are outside of the function, or not say outside, but it's not in the main part of the function where the function is either being squared or square rooted or cubed or the denominator or whatever, these are going to cause vertical shifts. And so the plus a would be what you would think, which is up a. And then the minus a is down a. So although for the horizontal shift it was opposite of what you'd think, for the vertical shift it was exactly what you'd think. Okay, now hopefully these two have kind of become second nature to you. It's the next few that we really need to understand better this year than maybe you've understood them before. So notice here I have an a on the outside of f of x. Anytime you're doing things on the outside part of the function, or to the entire function is another way, this is affecting the range. This is going to be a vertical change. So just like how when we added or subtracted a, that was a vertical shift, this is going to be a vertical. Now it may be a stretch or compression. It really just depends on what a is. And with vertical changes, it is what you'd think. So it is going to be a vertical stretch if the absolute value of a is greater than 1. And it is going to be a vertical compression, or sometimes that's called shrink. I'm going to mostly use compression though. And that's going to happen if the absolute value of a is less than 1. Now we're using absolute values here because if a is actually negative, that's going to fall into this category number 7, which we'll talk about in a minute. So number 6, notice that the a is on the inside. This would be like multiplying what you're squaring, or what's in the denominator, or what you're square rooting by a value. This is going to be a horizontal change. This is where you're changing your domain. All right, now you're still going to have the options of stretch or compression. All right, but if you remember, it's opposite of what you'd think, meaning you'd think a big number would be a stretch, and it is when you're vertically stretching something. But actually, this would be a horizontal compression. This is a little hard to communicate over a video that's not actually videoing me, but I like to tell my students to imagine that they had built something out of Play-Doh, and if they vertically stretch it, okay, it would make it taller, and that would then make it skinnier, which would be a horizontal compression. So whenever you have a number larger than a, let me kind of connect these in blue. Whenever you have a number, when your a is larger than 1, sorry, meaning you're multiplying the outside by a number like 2 or the inside, it's not going to do the exact same thing, but the end result will be very similar. It will either be tall or it will be skinny, although those look very similar. And sometimes we even use the word narrow to describe that. I know we do when it's a parabola. All right, and so a horizontal stretch would be similar to a vertical compression. Now, I say similar because it's not the exact same thing, but this may be a way that you kind of remember it. Think about this. If you're making something with Play-Doh and you vertically compressed it, meaning you made it shorter by smushing it from the top and bottom, it would come out the sides. It would become fatter. That's like a horizontal stretch. If you have questions about that, or if you'd like me to visualize it in class, I can definitely do that. All right, 7 and 8, definitely going to be our reflections. Just if you don't know which one is which, think about the pattern. Every time we've multiplied the whole thing by something or done something to the entire function, that has been a vertical change. That is affecting the entire range. So this is going to be a vertical reflection. Now, if you're just talking about something pretty simple, and you're just talking about one transformation, this is going to be a reflection across the x-axis. So when I say vertical reflection, I mean top to bottom, bottom to top, like a handstand. Right? If that negative is on the inside, that is going to be a horizontal compression. So as long as you haven't done tons of shifts, then this reflection is going to be across the y-axis. Now sometimes these things don't affect the graph at all. And we saw that in the short little part of the chapter where we tested for symmetry across x-axis and y-axis and origin. Things that are symmetrical have certain symmetries. They're not affected by this negative. Think of like a parabola. Y equals x squared. If you make that negative x in parentheses squared, it's the same thing. So it all ties together. Okay, these two, now you were looking at these thinking, ugh, I remember these from last year, don't want to do them. Well, I always have students say that it's much easier the second time around that they learn this. Okay, instead of going through and explaining this to you in words, I'm going to explain this to you in a picture. All right, so I'm going to draw a simple graph. Now, not simple by any means that its equation would be simple. This would actually be a piecewise function. Okay, but let's say that's our graph. All right, now what we want to do, if we're taking absolute value of the whole function, this is like taking absolute value of the y values. Okay, remember we've got our x-axis and our y-axis. Okay, everywhere where the y value is already positive, it will not change if I take absolute value. So what I'm going to do in my red, which is representing my new function, is I'm going to go ahead and darken in everywhere where the absolute value of y was already positive. Those points will not change. All right, however, this whole part down here below the x-axis where the y value were negative, we are going to recreate those points, but where the y value is positive. What that's going to end up doing is a reflection, okay? So it's going to be a reflection across the x-axis, not for the whole function. Okay, so I'm going to reflect that piece, but for just the part of the function where the y values were negative. So notice that it has to come down and meet. You can't just connect the points. It's going to come down. If there's zeros, those points stay there. Okay, so what I have here in red is the final graph. Now you do what you need to do on your notes to make sure that you understand that. This black part right here, the original graph, no longer part of my final graph. If it was, I would have something that is not a function, and that's an easy way to know that you're doing your transformations right. If what you have is not a function, then you did something wrong. All right, so now, like I said, write down whatever you want in words. I've written this many different ways, but ultimately I find that if students don't understand what's happening, no amount of memorization is going to help you remember this. And especially since this is the second year you're learning this, you're definitely going to be expected to recreate this on a quiz or a test. Okay, so I'm going to try to recreate that graph that we had in the very beginning. Okay, so this is what we had. And now let's talk about number 10, which is taking absolute value of the x's. This one's a little weirder, but it does make sense if you think about it. If you just try to memorize what I'm doing, that's really not going to work. I want you to try to let the logic of this pull in. So if I'm taking absolute value of x, this is not really just affecting the outcome. It's even affecting whatever you input in for x. So whether I plug in a positive value like 5 or a negative 5, it will actually give me the same output. So all of these points right here where the x value is negative, it's like those points got amnesia and they don't know where they're supposed to go. So let me re-explain this. All of these points right here where the x is negative, they no longer exist. They don't really even change or move. They just completely cease to exist. Okay, there is going to be something that happens over here. But now let's look at where the x value is positive. Well, if the x value is positive, just like up here, these points are going to stay the same. So taking absolute value of a positive number doesn't really change anything, so definitely we're going to keep all these points. So now the question is, what do we do with this other part? Now, I see some students wanting to reflect that over, but I just got through telling you that you know you're making a mistake if what you have left is not a function, if it doesn't pass the vertical line test. So let's go back to what I said originally. These points over here, the x value is negative. It doesn't move or anything. It's just nothing happens with these points. They just poof, go away. And what happens instead over here is anytime you were to plug in a negative number, well, it's just going to copy what its positive counterpart would have done. So let's say this was like, this point up here was like where x equals 5. Well, if x equals 5 gives me a y value up here, well then negative 5 for x would do the same thing. So we're going to get this copycat. And really, copycat is the best way to explain it. And your end graph should definitely be symmetrical. Okay? Now, one thing about order, because we're going to get to where we're having to do many transformations in one. One thing about order you might want to write is you want to work from the inside out. So you want to get right next to the x, and when you're writing down your transformations, figuring out what order they're applied, you want to do what's right next to x first. The exception is this absolute value. Okay, so let's write this down. The exception would be absolute value of x. This would always be the last thing you do. Okay? All right, so let's do some examples. So this is the graph of y equals f of x is shown on the same set of axes graph, and then they give it to you. Now, when you did this last year, you had to do a table of values, and, you know, that might have been kind of confusing, or you might have gotten it, but we're going to list these transformations out. And if you can do these transformations with something like this that's strange, then certainly you can do it with something you're familiar with, like a parabola or a cubed root function or something like that. So let's start with right next to the x, this 1/2. What is this doing to the graph? It's a horizontal change because it's right next to x, but is it going to be a stretch or a compression? Now, if you remember what I said, numbers less than 1 multiplied by x give you a horizontal stretch. So we're going to just kind of jot down what the transformations are. So this horizontal stretch really is going to make this thing twice as wide. Okay? So I'm going to go ahead and I'm going to be doing these one at a time and then erasing them as I go. Okay? And maybe changing up the colors. So you do what you need to do so that you get the final graph. Some of you, I think, could do this all at once. So instead of this point being at -3 away from the middle of the graph, we're going to make it here. And this point, instead of being just 1 away from the middle, we're going to make it 2 away. Now, points that are already in the middle, they just stay where they are. This point is going to be twice as far. This 3b is going to become a 6. And notice that I'm not really making that little semicircle or half ellipse any taller. It's just, that's the horizontal stretch. Okay, next, working our way inside out, I have a vertical reflection. Okay, now I'm going to go ahead and switch up the color here. All right, I'll even underline this in blue. So a vertical reflection is going to flip this up right here. So this point is going to become right here. Points that are on the x-axis stay where they are. So everything just gets flipped upside down. And since there's so much going on in the graph, I'm going to actually completely erase what I did in red. So all I have to work with is the end product. Okay, so now let's do the last thing, which is up 2. All right, so you just move each point up 2. Like I said, you get good at this, you could do all of these things at once. That's not the expectation for everybody. Everybody just needs to work at their own pace. And what I have here in green is the final answer. So I'm going to totally erase everything else that I have. Okay, let's go ahead and do the next problem. So working our way inside out, I first see that there's a left 2. Okay, so let's move everything to the left 2. Notice that this is the same strange function. It's just a piecewise function. We're not really caring so much what the equation is. We can completely work with this without even knowing the equation. That's the nice thing about graphs and transformation. Okay, so that's the left 2. All right, now this absolute value is around the whole thing. So this is where we take absolute value of y. So again, let me explain what we're doing here. All the places where the y value is already positive, those aren't changing at all. Or where the y value is 0, like the x-intercepts here. That's why I went all the way down. Even this point over here, not changing. What is changing is where the y values are negative. Those points alone, just these 2 little pieces, those points are being reflected up so that their y values are positive now. And that's how you take absolute value of the y, or in this case, absolute value of f of x. And then what I have here in blue is my final. Okay, let's look at the next page. All right, so again, we work our way inside out. So the first thing we want to do is a horizontal reflection. I know that it's horizontal because it's being multiplied to the x and not to the entire function. So a horizontal reflection. This is a reflection across the y-axis. So this point right here in the middle stays. These pieces right here are going to be horizontally reflected over. And then these 2 pieces right here are going to be horizontally reflected over. There we go. That's the first part. All right, now let's look at the 2. The 2 is being multiplied to f of something. So this is going to be a vertical stretch. And I know it's stretch because it's a number larger than 1. And it's vertical stretch, all right? I chose to do this 2 because, again, I'm working from the inside out. So I want to vertically stretch it. I want everything to be twice as far away from the middle. In this case, the middle is the x-axis. So I'm going to make that twice as far. Okay, I'm going to make this point. This is at -3. I'm going to make it go all the way down to -6. And I'm just taking a piece at a time, not necessarily going from left to right, and making sure that I cover everything. This piece, I just realized I did that first one a little bit too. Oh, never mind. That was fine. This, though, is going to get taller. There we go. And I find it confusing to have several different graphs on one, so I like to erase as I go. Once I'm done with something, I erase it. Okay, last thing, what's that -1 going to do? That's going to be down 1. So move everything down 1. Exactly as it is, but down 1. Oops. I'm going to go ahead and erase that blue. We don't need it anymore. And if you got lost on any part of this, just rewind the video, rewatch that part. There we go. Final answer in green. Okay, last one we're going to do together. Remember I said the exception from working inside out is this absolute value, so that's actually what we're going to do last. So the next thing is this -2. It's inside the parentheses. So that's going to be a shift to the right 2. Now if you're feeling up for it, I think this is a good one for us to go ahead and try to do 2 transformations in one. Since it's a right 2 and then this +1 is going to be up 1. Now the last part we'll do on another step. But let's move everything right 2, up 1. Right 2, up 1. If this is confusing, just go back and take it one step at a time. Okay, there's no one saying you have to do it this way, but I think you guys are at the point where you could do these two transformations. All right, at one time. All right, so absolute value of x. Absolute value of x. Okay, remember, this is where the points where x is already positive stay the same. Because taking absolute value of a positive number doesn't change it. So all these points, they're good. They're going to stay the exact same. Now, these, and it's just a short part on this one, these points right here, x is negative. They're not going to move anywhere. We're not going to do anything to them. We're going to completely erase them. And what happens over here is that all these points where x is negative are going to copycat the points where x is positive. So what's going to end up, it's going to look very symmetrical. And just make sure that whatever you graph is a function. You can catch a lot of mistakes by just doing a simple vertical line test at the end of your graph. There you go. This is definitely something you would be expected to do. Any of these, but definitely 4 as well. Okay, bring your questions to class. If you look on this packet, that's going to be your assignment, and so we'll work on that in class together.